All right, so we're going to start off by talking about the structure of an atom today. You all should have this sheet. This is going to be your sheet for notes. Please make sure that you type down all your, or put down all your answers, handwrite them, and then you'll submit this as evidence that you took notes. So first off, structure of the atom. These are symbols. If it's a proton, it's a clear. If it's a colored in with black, it's an electron. If it's colored in gray, it's a neutron. And you can see that it's not going to be perfect on yours because yours was a copy, not the original. So you may want to color in, pause this and color in where your electrons and everything are at, okay? And you can see them all here. So anyway, here we go. So we got this first hydrogen here, and you have one proton, one electron. This hydrogen here, you have one proton, one neutron, one electron. And here you have one proton, two neutrons, one electron, and so forth. And you can read the rest of this and count them as you go, and we'll come back to those. This symbolism that we see here is the AZX way to show what the atom has in it. A is the mass number, so this top number where the 12, the 13, and the 14 are in carbon, that's the mass number. This bottom number, Z, is the atomic number, 6, 6, and 6 for carbon. And then X is the chemical symbol, which in this case is carbon, and for this one is hydrogen. All of these are carbons, and they're called isotopes of carbon. All of the H's are hydrogen, and they are all isotopes of hydrogen. And the part of the atom where the protons and neutrons are called is, of course, the nucleus, which you should know already. Okay, so those are the diagrams we're going to be looking at to answer some of these questions. So first question, how many protons are found in each of the following? So let's look at our H's. All right, this first H has one proton, the second H has one proton, and the third H has one proton. So we're going to say 1, 1, and 1. So we got one proton in each. How many neutrons are found in each of the H's? So let's look back at our H's. Let's count our neutrons. This one has 0. The second one has 1. And the third one has 2. So we got 0, 1, and 2. So we go 0, 1, 2. So we get 0, 1, and 2 for the neutrons. And then electrons. How many electrons are found in each? Each hydrogen has one dark spot, so therefore each of them has one electron. So we will label that as 1, 1, 1. Now, so what characteristics do all hydrogens have in common? Well, all the hydrogens have the same number of protons, same number of electrons. So same number of protons and electrons. What structural characteristics do all carbon atoms have in common? So let's go back to carbon, and you can see they all have 6 protons. And if we were to count the black dots, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, they all have 6 electrons. So same number of protons and electrons. What does the mass number tell you? Okay, so the mass number, when we look at it, for this is 12, for this is 13, and for this is 14. 6 plus 6 is 12, 6 plus 7 is 13, 6 plus 8 is 14. So the mass number, right, mass number is equal to protons plus neutrons. Now, can you find the mass number of element on the periodic table? Short answer, no. And I'm going to put a couple exclamation points because some people think that you can, and you can't. And we'll go in more detail of that when we talk about average atomic mass. But just understand that the mass number is not on the periodic table. Now, what does the atomic number tell you? So that's the number at the bottom, 6, 6, and 6. It tells us 2 things with carbon and 2 things with hydrogen. It tells us the number of protons and the number of electrons. Now, some will argue that that always tells us the number of protons and electrons, and I'm going to say it doesn't. And again, we'll get into that here in a second. So the atomic number only tells us number of protons. Okay. And can you find the atomic number of an element on the periodic table? A resounding yes. It's the big number next to each of the element symbols that you see. All right, so define the term isotope. This is a tough one. So these are all isotopes of carbon, right? So we got 6 protons, 6 neutrons. This one has 6 protons, 7 neutrons, and this one has 6 protons, 8 neutrons. So how do we tell them apart? Well, it's very simple. They're isotopes because they have the same number of protons, but a different number of neutrons. Let's look here. Hydrogen, 1, 1, and 1 proton, 0, 1, and 2 neutrons. Same number of protons, different number of neutrons. So isotopes, elements that have same number of protons and different number of neutrons. And the question should be pretty simple. How does one isotope of carbon differ from another isotope of carbon? Number of neutrons. And that's how we tell the difference, okay? So that's page 1. All right, so page 3, atoms, ions, masses of subatomic particles. So the AMU is called the atomic mass unit, and we use that because atoms are so small that just a single AMU, and you can see this is this, right? 1.66 times 10 to the negative 24 grams. That is very, very small. And so if we tried to use that to measure masses of atoms, we would be dealing with really, really small numbers, and the math would get very hard to deal with, especially with all those exponents. So what we've done is we made one AMU equal to that number, okay? 1.66 times 10 to the negative 24. So here we go. Let's look at AMUs and see if we can figure some things out. So first off, we have the fluorine atom, 9 protons, 10 neutrons, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 electrons. Then we got the fluoride ion, which has 9 protons, 10 neutrons, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So the difference between the two is going to be we have 9 electrons on the left and 10 on the right. And then magnesium, 12 and 12 each. If we count the electrons here on the left side, we should get 12 electrons. If we count the electrons on the right side, we should get 10 electrons. So different number of electrons, all right? So what's structurally different between an atom and an ion? And it's the only difference, okay? What's different is the number of electrons. In fact, we could say negative ions. So negative ions have more electrons than protons. And then we got the magnesium, which is positive. Positive ions have more protons than electrons. All right, so that's how we can tell the difference between atoms and ions. What is the mass of an electron? Well, if we look here between these two, right, the fluorine atom has this for its AMU. The ion, which has 1 more electron, has this. So if I take this number minus this number, it should tell me the mass of a single electron in AMU. So if I take 18.9985 minus 18.9980, that should tell me the mass of a single electron, which would be 0.0005 AMUs. So that's the mass of a single electron. Is most of the mass of an atom located in the nucleus or outside the nucleus? How do you know? Well, let's say we know the mass of an electron to be 0.0005 AMUs. Here I only have 10, right? 10 electrons. I take 10 times that, it's 0.005. And this is our total mass. So therefore, we know most of the mass lies in the nucleus, okay? So is most of the mass located inside or outside the nucleus? Inside the nucleus. And how do we know? The electrons have very little mass in relation to the mass of protons and neutrons. Now, if protons and neutrons had the same mass, what is the approximate mass of a proton and neutron? Well, if you look really close, I got 19, and this number rounded up is 19. It's approximately, okay? Protons, whoa. Lost my text box there. Protons and neutrons have a mass of about 1 AMU. That's approximate, but about 1 AMU. So the mass of 14 carbon is about 14 AMU. Does this agree? Sure does. I mean, and again, it's approximate. We tend not to really kind of worry about the mass of the electrons since they're so small in relation to the total mass. So the answer is yes. The charge of a symbol is in the upper right hand corner. Okay, why isn't it net positive 1 or some other number? So if we look at fluorine here has this -1 charge. That -1 means that we have more electrons than protons because we have 10 electrons and 9 protons. So when they ask that question, why isn't it positive 1 or some other number? And it's because we have 10 electrons and 9 protons. And it works like this. Since electrons are negative, I take -10 plus my number of protons 9, and that equals -1, which will be my charge. 16, what is the charge on every atom, and why is this the charge? Well, look at the atom. I have 9 protons and 9 electrons. Here I have 12 protons and 12 electrons. So why is that the charge? The charge on every atom is 0 or neutral. And why is it the charge? Because the number of protons equals number of electrons. And so how do you determine the charge of an ion? You take, like we did there, you take protons minus electrons. And if it's a negative, it's a charge. It's a negative charged ion, and if it's a positive, it's a positive. Okay. So hydrogen ion has a -2 charge. How many protons does an oxygen ion have? So periodic table, oxygen right here has 8. On the right hand corner here has 8 protons. How many electrons does an oxygen ion have? So if we have 8 protons minus X, which is our number of electrons, it should equal a -2 charge. So 8 minus X equals -2. And so if I do the math of that and I go subtract 8 from each side, -X equals -10. X equals 10. So that means it'll have 10 electrons. And we'll do some more math with this stuff. I just wanted to give you a background in the structure of an atom. Please fill this out and please submit. Thank you.